Mm-hmm.
Okay, let me try once more.
Okay.
Now tell me, can you see
Now,
sorting and separation of material is written?
yeah. Yeah.
Okay, okay. You just stop your cursor. Maybe it may be disturbing. Okay, you just listen to me. If I will make you write somewhere, write on a copy, you just don't move the cursor. Maybe it may has created some problem. Okay, let's begin. So this thing I have discussed just the what is the syllabus. So can you read the earth is one large mixture of gases, liquid and solid?
I don't see any writing.
No, anything written the slide?
I see sorting and separation, and on the top right corner, I see sorting and separation, and I see Olympiad success in the left corner, and I see class VI on the bottom.
And nothing in the between.
No.
Okay, leave it. Leave it. Maybe I don't know what is an issue, but you listen it. Okay, the slide is important. It will be delivered to you. Just listen to me. What has happened? I don't know. But you listen to me. Okay. So it is saying now Earth is one large mixture of gases, liquid, and solid. As we know now, we have a three states of matter: solid, liquid, and gases. As you previously said that you know all these things. So Earth is a very big example. It is a composition of all the three matters. Okay, solid, liquid, and gases. So what is matter? Can you define me what matter is? Anything which you know about matter.
Matter is like the space, the amount, the space inside of like an object is like the matter inside of the object.
Okay, so matter is something which has mass and
Mm,
occupy space.
okay.
Matter is something which has mass. Can you see I'm writing mass? Can you see I am
Yeah, I
writing?
can see the writing.
Is it visible? I wrote just mass. Can you see that?
Yeah, I can see it.
Okay, okay. My writing is not so good here. Okay, so anything which has mass and occupy space or volume,
Mm-hmm.
space or volume
Mm-hmm.
is called matter. So you are a matter, I am matter. Anything which occupies space has mass. Even an ant is a matter. If you go to the subatomic particle, atom, inside atom we have electrons, protons, neutrons, all are matters. Even if you go outside this world, sun, moon, so everything which has a mass and occupies space is matter. Now can you think of anything which is not a matter,
Mm, like all the
which cannot
objects
have,
around,
which don't have mass but it exists?
all the things around us, and including us too. Everything in the world.
Anything else which is not a matter? Anything which you can guess? Anything which
So
doesn't have a mass but it exists?
everything has a mass.
Everything has a mass. Does light have a mass?
No. Oh
So
yeah.
is light a
Like
matter?
no.
Yes, very good. As next example could be, is sound has a mass?
No.
So is sound a matter?
No.
Okay, you are thinking something. You are in this planet Earth. We are on this planet Earth and we are thinking something. Does thinking has any mass?
No.
No. So all these things which I give an example, there are many. Okay. So I just gave you a few examples. So these are the things which exist, but it doesn't have mass or it doesn't occupy the volume. Okay.
Mm.
But all the physical objects has mass, which you see, which you feel, which is around you is
But liquids and gases don't have mass.
Yes, gases have mass, no doubt. Yes,
Mhm.
gas have weight, na?
But
Gas
how
have
do you
weight.
weigh gases though?
How do you?
You weigh gases.
How do you weigh gases? Very simple experiment. You just take two balloons. In one balloon, you fill air. In another balloon, you fill some another gases. For example, if you are filling nitrogen gas, the gas balloon is going up. Have you seen that?
Mm-hmm. Yeah.
So why it is going up? When you are blowing that, when you are filling the air with the mouth, that balloon is not going up, it is going down. So the nitrogen gas is lighter than the air. Air is heavier than the nitrogen gas. Okay. So this simply shows that a gas has a mass. And if
Mm-hmm.
even you can just measure in the weighing machine as well. If the balloon
Mm-hmm.
is filled with air, and if it and the balloon which is not filled with air, so both the masses will be same in the weighing machine.
Mm-hmm. No.
No. So this means air as a mass, gases as a mass. Second example, in India we use a gas cylinder. Okay. So the gas cylinder weight is around 30 kg. Filled gas cylinder weight is 30 kg. So okay.
Mm-hmm.
So it is very difficult to pick up to the fourth floor or first floor. It's very difficult. But when the gas has just ended and now we want to refill, that becomes lighter, approximately 10 12 kgs. So that shows now that gas has a weight. We are using it in daily life experience. Okay.
Mm-hmm.
So is the screen visible, Tanuj?
Yeah.
What it is written?
For mass and space.
What it is written?
Mass and space.
Can you write? Can you see states of matter written over here?
Yeah, I see mass and space.
Only
Uh,
mass and space.
states of matter? No.
Only
I
mass
only
and
see
space.
I see like a big black line and like a black dot.
I got it. I got it. You are not able to see the screen. Okay, I got it. You are able
I
to
can
see the screen, but you are
see,
not able to see the slides inside the screen.
yeah, I
Okay,
can
no
see the
problem.
mass and space.
Mass and space now I have deleted.
Yeah.
Okay. Do you have a writing? Rubbing. Okay, so generally we speak now, we have five
Mhm.
states of matter. Five state. How many?
Five.
Five
No,
state.
three.
Three.
Oh, this
Yes,
one?
three is solid, liquid, and gas. But for your
Mm-hmm.
extra knowledge, I am giving, there are five states of matter. Now you can see my screen.
Wow.
Bose-Einstein condensate. Bose-Einstein condensate is the first. Second is solid. Third is liquid. Fourth is gas. And fifth is plasma. Can you see all those four things written?
I know plasma. I know plasma, but I don't know what's Bose-Einstein condensate.
Yes. So this is a topic of research. Still, the research is going on these plasma and Bose-Einstein condensate.
The
So this
plasma is like
Bose,
on the sun. The
what?
plasma is on the sun, right?
Plasma, okay. So Bose was Indian scientist, Chandra Bose,
Mm-hmm.
J.C. Bose, and Einstein. So they were at both were in the same time. They were doing the research in the same time. Okay. And they postulated a theory that there could be a one more state of matter which works in extremely low temperature. Low means freezing, beyond freezing temperature. So at that temperature, what happens now? The electrons come out of the orbit. So it
Mm-hmm.
makes a something different. And at that time, when they were doing the research, there was no equipment, there were no scientific equipment or anything to measure it. So they just postulated and theoretically they wrote that it may exist. But recently in year 2000 something, some scientist came and they visualized what Bose-Einstein has proved, has postulated, has written in a theory. Now it is visible. So it is included as the fifth state of matter. And similarly, plasma is a state of matter which works or which exists in very high temperature, the temperature beyond our imagination. And what we say is that 99.99% of the universe is made up of plasma, but we don't use plasma. So it's talking about universe, the whole space.
Mhm.
The sun is a heavenly body, it's a very big, but where the sun is in the space. So space, can you imagine how big the space is? So that space part is said to be plasma. So now in the sixth grade, we are not going to very deep into this, but just for your knowledge, we can say that there are five states of matter. Both Einstein condensate, we can say in short BEC, solid, liquid, gas, and fifth one is plasma. But in your syllabus, it is only three: solid, liquid, and gas. Clear? Now, how you will be distinguishing the different kind of material, which is solid, which is liquid, which is gas, just by the physical appearance or by touch and feel. So we can see we can differentiate with the appearance. Yes or no?
Mhm.
Appearance means if you can smell, if you can touch, if you can feel whether the thing is soluble or insoluble, whether that solid is soluble or that solid is insoluble. In terms of metal and non-metal, you can also feel the metal, which one is metal, which one is non-metal. Okay.
Oh yeah. Oh, I was on the first page.
So
That's why I could see your writing.
you come to fourth page.
Okay. That's the reason I couldn't see your writing.
I am in fourth slide. Do you have an option of switching the slide?
Yeah, I can.
Come to the fourth slide and say me what it is
Yeah,
written.
I am. I'm in the fourth slide.
What it is written?
Um, like sorting materials based on appearance, color, texture,
Oh,
or
so you also have to change the slide with me. Okay, that I
um,
didn't know. Okay. Just go through it. So can you tell me what these three figures says about these three figures? The first one, this one.
uh, the first one, it's like a solid, just like tightly packed
Very good,
together.
very good.
And then I think the second one in the middle is liquid because it's like kind of it's like kind of a bit
Loosely,
looser,
loosely. You can say the
looser than
loosely
the
packed. Yeah.
yeah, it's looser than the solid, but it's not that loose. But then it's not but then it's not looser than the gas, and then all the gas particles they're scattered around.
Okay, very good. So gases are very loosely packed. Just to resemble what does loosely packed means in your real life, just apply the physical application. Suppose someone is using a perfume in a room next to you.
Mm-hmm.
So will you be able to feel the fragrance?
No.
The next room, someone is using perfume, spraying perfume. So don't
Mhm.
you feel the smell in the adjacent room?
Yeah.
Yeah. Why? Because gases molecules are loosely
Gas
packed,
molecule like spread around, so then
spread
it'll spread
around. It's very
around,
loosely
and then
packed.
it'll go to your room, and then you'll be able to smell it.
Great. Okay. So now liquid, why it is loosely packed? Why it is less than solid and more than
But
gases?
it takes the shape of
Shape,
any
take the
container.
shape. You just splash of water. You do
Yeah,
splash of
it can
water.
take the shape uh of any like shape.
Yes. And solid is rigid. Rigid means which cannot be moved. Rigid body, like
Mm-hmm.
metal, stable. So how they are distinguished. These are the compact molecular arrangement. So tightly packed is solid, loosely packed is liquid, and very loosely packed are gases. But all three are matters. Okay, now I'm moving to the next. Now here you can see na both and condensate, and it is written na
Yeah.
it is written na low
Yeah.
temperature.
Mm-hmm. Yeah.
Very good. Now I'm going to the fifth slide. So let me delete this one. How to delete it?
I can't go to the next slide. No reason I can't go to the next slide.
Fifth one, fifth slide.
Yeah, I'm on the fifth slide, but I can't go to the next one.
Changing states of matter. This is the fifth slide.
Yeah, I can't go.
Oh my God, what has happened?
Now it's
You are zooming or zooming out?
because like I need to see it. Cause like it's all the way up for me.
Is it visible now?
Yeah, I can see it. It's like this stove.
Okay. Now this slide says very simple thing. States of matter are interchangeable. Interchangeable means solid can be converted to liquid, liquid can be converted to gases, gases can again be converted to liquid, liquid can again be converted to solid. Is it possible? Can you cite me an example for that?
Um, like um, whenever you like heat, um, whenever you heat like chocolate, it'll melt and turn into like a liquidy substance.
Very good, very good. And how it will turn into gases? Have you
When
ever
you-
have you ever tasted the gas chocolate?
No,
No, but it is possible in case of water. Water has a solid state in terms of, tell me,
like of ice, and then it'll turn
ice, liquid
if
is
we,
water, and gas is
and then the gas is like the water
vapor,
vapor.
vapor, vapor.
Yeah,
So how does this transformation is taking place? Just by
because if
changing
you
the
heat it,
temperature.
yeah, heating it.
Just by changing the temperature.
Mm-hmm.
So temperature plays a very important role. When you will
Mm-hmm.
heat the ice, so the molecules will be disintegrated and it will turn into its original shape of liquid. When again you will heat it above 100 degrees centigrade, then it will evaporate. So it also proves that the conservation of energy, it's not getting wasted out. Not a single drop of water is getting wasted. It is just transforming from one matter to another. The states are changing from one state to another to another. It's evaporating. In summer, we say there is no water available in the underground. So all are evaporated due to heat. But in rainy season, what happened? The water coming back to the earth. Okay. So how does the matter changes one from to another? So we have one very important is temperature. Second is also second thing is pressure, which also plays a vital role. Pressure. You know what term pressure means?
Yeah.
Yeah, pressure is applying force per unit area.
Mm-hmm.
So this is what I just tell you. The extra energy allows the molecule to change the state. So what is that extra energy? That extra energy is heat. Last line. Can you read the last line? Where is my pen? Okay, now I'm going to move to the next slide, sixth one.
Okay.
Okay, so the same thing it is saying, the solid, when the energy is added, which energy is talking about? It's talking about heat energy.
Mm-hmm.
It turns to liquid. Again, heat energy is added. Which energy? Heat energy. It turns to gases. And now again it is added energy which turns to plasma, which is not possible on this planet Earth. Making a gas into plasma is something which is above beyond the Earth because it requires a lot of temperature. Okay, but yes, it is possible. So phases describe the physical state of matter. So physical state matter is changing one phase to another
Okay.
just by the transformation of energy. Here we are talking about the heat energy. So energy in sometimes heat is absorbed and sometimes heat is released. So when you will heat up, when you will provide a fire, make the thing heat, so heat is getting released. So the molecules are getting disintegrated. Disintegrated means it was tightly packed, now it becomes loosely packed because heat energy is playing a role. So the liquid state has come to the liquid state. But again, when you are heating up, providing extra energy, then that is turning into which form? Gases form. Okay, clear to you?
Yeah. Yeah.
So here we two terms are very much notable. One is freezing point and another is boiling point. So
Mm-hmm.
freezing point is a temperature where water turns into ice. What is that temperature?
Like the freezing point.
At what temperature water turns into ice?
Like whenever it's like whenever it's like too cold.
At what temperature I'm asking? At what temperature water will become ice?
Mm, like
In India,
one
we
degree.
don't have much places where we have a weather where we can feel ice except on Kashmir and some of the Ladakh. But in I hope in Texas you must be feeling in winters the all the parts.
Yeah.
Yeah. So what is that
Degrees.
temperature?
-9.
0 degree, 0 degree centigrade,
Uh, what?
0 degree centigrade.
Oh,
At 0 degree centigrade, water turns into ice. And at what temperature water turns into vapor?
like 70.
At what temperature the water gets start to evaporate? You must be seen now. Mother is cooking at your home and she is
Mhm.
boiling water. At certain point
Like
of time, the vapor are coming out.
70,
Okay, increase it, increase it. 70 is less, increase it,
90,
increase it.
100.
100. No, you write those, the two, write it to both the temperature. So 100 degree centigrade is known as boiling point for water, and 0 degree centigrade is known as freezing point for water.
Mm-hmm.
Clear?
Okay.
No, move to the next topic, next slide. Go to the slide number 7.
Mm-hmm.
Okay, now, as I told you, one important role was played by temperature. You just saw the example, 0 degree, 100 degree, etc. The second important role is playing pressure. So upon heating, why the food is cooked upon heating? Why we need to heat to make the food eatable? You cannot eat a raw dal or you cannot eat a raw rice. We need to cook it, boil it. So
Mm-hmm.
that in the pressure cooker. So now the name of the cooker is pressure cooker. This means it is applying some pressure. So it is the application of pressure. It's making those rigid body molecules, those compact molecules into loosely disintegrated. That's why that dal becomes in a liquid state and this rice becomes soft so that we can eat it. Are you getting?
Yeah.
So pressure is a physical effect that can change the melting point.
Mm-hmm.
Okay. So what it is written, it is easier to keep things solid where they are under great pressure.
Mm-hmm.
When we have a when you will apply the pressure to some object now, so it will remain in a solid state more in a solid state. Okay, now here you can see some terms are written. Fusion. Do you know what does fusion means?
Yeah.
What it is?
I think it's like I'm not. I think it's like a combination of a lot of materials.
Okay, next term. What is the next term is written? Can you just can you see what the next term is after fusion?
Melting.
What it is? Melting. You know, na?
Yeah.
Melt something which when you heat. Freezing, you know. Vaporization in you know
Yeah.
vaporization
Yeah.
and condensation.
Yes.
What it is?
It's like when the gas changes into a liquid.
Vaporization. Okay. Boiling, I just told you 100 degrees centigrade, it boils. Condensation is something which when you cool down, na, the temperature is brought down, so condensation happens. Like when you see the in the rainy season, you can see the mist on the glasses or the window. Okay. Fusion is something with two things are meeting to make it one. That is called fusion. Diffusion is removing of two things which have met already. Fusion, meeting of two things, diffusion, removing of two things which have met. Okay. So these are the terms of the chemistry. So we will learn. Okay, phase change. Listen here. Tanuj,
Mm-hmm.
phase change. Solid to liquid. Give me an example.
Solid to liquid.
What I just
When
told you, you can just cite what I told you, right?
like ice turning
I to
into
liquid to solid.
a liquid to solid. Is like when you're freezing the water.
Water and the example you gave like a chocolate at very high temperature,
Yeah.
chocolate will melt. When you will freeze it or will keep it in the freezer, it will become a solid. Liquid to
Mm-hmm.
gas.
When you evaporate water,
Evaporation height at what temperature?
at like 100 degrees.
100 degree, very good. Gas to liquid?
Gas liquid is like when you cool down
Cool
the water.
down, condensation. That is the term. Cool down, condensation. Okay. Solid to gas?
Solid to gas would be
So there is one process called solid to gas. Okay. So they here
mhm.
what is happening? What is happening?
You just keep on boiling it and you don't stop.
Definitely, but it will not be coming into the middle phase.
Mm, and how?
Solid to
Mm,
liquid, it is not coming into liquid phase. It is directly going from solid to gas.
mhm.
Similarly, it is directly going from gas to solid. It is called sublimation. What it is called?
Okay.
Sublimation. You can write it, sublimation.
Mm-hmm.
It skips the one phase. Solid to liquid, liquid to gas is the stage. But when it is directly goes from solid to gas, it is skipping the liquid phase. So that process is called sublimation.
Mm-hmm.
So can you cite an example of sublimation?
Mm, when the rock particles, um, when the rock particles get broken down into smaller pieces.
Ask your mother must be using in winter that to keep that all those woolen clothes. So she's using one tablet type of thing called it as naphthalene balls. We
No,
call
she doesn't.
we call it what we call it. So in India we use it when in the when the winter is over now. So we used to keep that camphor बोलते हैं उसको. We used to do camphor ball, naphthalene
Mm-hmm.
or camphor.
Yeah, I know camper.
So what we do now, we put it on the woolen clothes and we keep it in the next season. Next season, when we open the clothes, now that is evaporated, gone.
Mm-hmm.
That whole ball is gone. So it directly converts from solid to gas, but it
Mm-hmm.
leaves the smell. We use it just to that it doesn't smell bad. Okay.
Mm-hmm.
And the second example is very good example that is called solid. Sorry, that is called dry ice, and dry ice is also known as solid carbon dioxide.
Mm-hmm.
So have you heard the term dry ice?
Yeah.
Ah. So dry ice directly converts solid to gases. It doesn't come into the liquid phase, but it releases lots of carbon dioxide. Moving to the next slide, slide number 8.
Mm-hmm.
So it is the same thing what I just told you. It is just a diagram or mental map diagram so that you can easily grasp the image. This image, you should bring it in your mind. So whatever I taught it is just in a one simple image. Solid to liquid by what it is saying,
Mm-hmm.
melting,
Okay.
but liquid to solid, freezing. Can you relate it?
Yeah.
Okay. See, solid to liquid, melting.
Mm-hmm.
Liquid to gas, vaporization. Gas to plasma, the word is ionization. Ions are disintegrated. Now it's too early to define what ion is and how it is disintegrated. But if we given time, I can explain you. Okay. Similarly, coming back, now plasma will come to gaseous state by the recombination. Those ions which are disintegrated, they will come back and integrate itself. And now gases will turn to liquid by condensation. You know this term.
Mm-hmm.
Uh, and gases will directly turn to solid by the process called deposition.
Yeah.
And liquid will turn to solid by a process called freezing. So these are the
Mm-hmm.
terms you must be very much clear. It should be very much clear to you. It should be very much handy. When I say sublimation, you should know what sublimation means. When I say condensation, you can relate what condensation is with an example. Okay.
Okay.
When I say fusion, fusion means meeting of two things. So you when I say the term fusion, the image should be in your mind. Fusion means meeting of two things. For example, the gases are meeting and making a hydrogen and oxygen, making H2O. So this is the fusion. So there are two types of reaction of nuclear fusion and nuclear fission. The sun is doing this fission process every second. And the same diagram, it has been made here. Okay.
Mm-hmm.
Okay, now we will be moving to the next slide. Slide number 9. Can you see this?
Yeah.
Okay, let me rub these sticks. Let me zoom. How to zoom? Now see, matter is classified again into two,
Mm-hmm.
mixture and pure substance. Mixture, you know very well, mixing of two substance. Pure substance is something which is very much pure in nature. But
Mm-hmm.
that doesn't mean pure means it doesn't have any external particle. Yes, pure. We are drinking water. We are drinking which water? Pure or impure?
Pure.
Which water we are drinking? Pure or impure?
Pure.
Pure. But does water contains only water? It doesn't. It does. It water has some other component. Does it have magnesium?
Mm,
Does it have iron?
yeah.
Does it have chlorine?
No.
Yes, it has. Water has many elements stored in it at very, very small amount. Water
Mm-hmm.
has many types of salt in it because we
Mm-hmm.
can't drink distilled water. Distilled water is a water which is evaporated and then collected. So it loses all its properties. So that water is not going to provide any health to us. That will make a loss of our health. So we use those water which is full of all the salts. But
Mm-hmm.
we call it pure substance. So there are two kinds of pure substance, one which cannot be separated and another which can be separated. So what I give an example was water. So water is a pure substance, but it can be separated. We can eliminate RO. You must be using RO. We are using RO at our home for filtration. So what it does, it removes the extra salts. It removes the extra TDS, but is not helpful for our health. But element is something which is pure, which exists in nature. It cannot be separated. Hydrogen,
Mm-hmm.
helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, aluminum. These are all elements. You cannot change it. Yes, you can mix it. For example, iron can be mixed with copper. You can make an alloy. Gold is mixed with copper. Are you getting? But it can be by melting, you can separate a gold, you can separate the copper. So pure substance are separable as well as inseparable. Inseparable, which cannot be separated, are called elements, which are very pure. And the pure substance, which can be separated by some chemical reactions, are called compound. Compound means mixture of two or more elements.
Mm-hmm.
Similarly, mixture can see the parts like homogeneous and heterogeneous. Note it two terms. Homogeneous, same. Homogeneous, same type of mixture.
Mm-hmm.
For example, mixing of milk in water or vice versa.
Mm-hmm.
So it is a homogeneous mixture. But heterogeneous, mixing of two different materials like sand and water.
Mm-hmm.
For example, petrol and water. Petrol and water is what? Homogeneous or heterogeneous?
Petrol and water is like homogeneous.
No. Oil and water never meets. Oil is lesser denser than water, so oil will float on water.
Yeah.
Oil will float on water. You can do it at your home in the kitchen. You can say, now you can check by mistake if oil is oil is poured in the water or vice versa. So you can see a layer of it.
Mm-hmm. Yeah.
Yeah. So that is not a homogeneous, but that is called as heterogeneous. Are you clear with all the terms? Homogeneous mixture, heterogeneous mixture,
Yeah.
compound and element. You can ask. You can ask the note. It's an open discussion. You can ask me any type
Mhm.
of question.
Okay.
Is it clear? Can we proceed, or you need more discussion, more example?
We can proceed.
Very good, very good. We'll see the examples later on.
Mm-hmm.
Now, pure substance or mixture. In the left side, can you tell me, have you clicked for the 10th number slide?
Yeah.
Okay, very good. So in this lots of example, is there anything which is pure or all are
There's
mixture?
water, the water.
Water, very good. Next,
Mm, that's basically, and then probably like sugar.
all are the mixture. Honey is what, pure or a mixture?
It's like a mixture.
Honey is a mixture. Okay, all are compounds. Okay, so what are the properties? See, what are the properties? Separation. It can be separated into its component. If it is a mixture, it can be separated. One property. The
Mm-hmm.
chemical property of the mixture are the same as those of the component. If two components are mixing together to form another mixture, the chemical property will remain same. It will not be changed. Energy, no energy takes place when formed. When two things are made to make one
Mm-hmm.
thing, or you are making a mixture, so there is no change in energy. That is, no heat or light is taken away, or exothermic or endothermic. There is nothing like that. And the fourth property is composition. Composition means the substance in a mixture you can mix in any proportion. It's not necessary that you mix equal water and equal milk. A small amount of milk in a small amount of water can also be mixed into a milk, and vice versa.
Mm-hmm.
Okay, so these are the one, two, three, and four properties of the mixture.
Mm-hmm.
Can we proceed further? Can you proceed further, Tanuj?
Yeah.
Very good. Mhm. So another term is solvent, solution, solute.
Mm-hmm.
What are these things? Can you guess? What are solvent? What are solution? What are
The
solute?
solvent is like another substance, and then solute is another substance, and they mix together to make like a solution.
Very good. So solution, to make a solution, we need some liquid. That liquid can be said as solute. And if you are making, what you can say, if you are making some lime soda and you need to add sugar to it. So in that lime soda, what is sugar? Solvent or solute or solution?
Um, the sugar is like the solute.
Sugar is solute. Very good. Your understanding is clear. Okay, so here are lots of examples you can see now. Here, uh, let's see what are the solvents. So water is a solvent. Here, lemonade mix is the solute. Lemonade mix is solute, and that lemonade which you have made is a solution. Iced tea is solvent, sugar is solute, and that sweet tea is what? Solution. Milk is a solvent, and if you add anything in milk, if you add Bonvita, chocolate, or milk, or sorry, sugar, anything is solute, and that particular thing which you are drinking is called solution. Similarly, boiling water and jello powder, it's make a jello. Jello is something like jelly type of substance, na? Very good. So it is clear with all the three terms,
Yeah.
solvent, solute, and solution.
Mm-hmm.
Okay, can we proceed?
Yeah.
Now, you can see now, soluble versus insoluble. There are two types of substance,
Mm-hmm.
soluble versus insoluble. Soluble substance means it will dissolve completely in it, like salt and water.
Mm-hmm.
Insoluble substance, which will not mix together. So if it is mixed salt and water, is there any process to extract salt and water?
No.
Yes, we
Well,
have. We have.
a desalination.
Yes, we have 2-3 meters. If oil and water is mixed, can it be removed? Can we make it separate?
No, I don't think so.
Yes, we have. So what are
Oh.
those methods? These methods we are going to learn in our coming classes. How we can separate the toughest substance. How we can separate a mixture of milk and water. How we can separate a mixture of oil and water. How you can separate crude oil coming from earth into diesel, petrol, kerosene, coal tar, etc. Lubricants. Okay. So we have a whole factory set up. Whole factory is set up. Oil companies are set up a whole factory and whole process of extracting the different material. And this works mainly with the temperature variations. When the
Mm-hmm.
temperature varies, so we'll get a pure substance and less pure substance, etc. So this is very interesting topic, and it is highly applicable. Okay, I'm just move to the next slide. Read it what it is written.
Mm-hmm.
13.
Yeah. Miscible and immiscible.
Yes. So it's the same thing what you just read. Miscible and immiscible. Miscible, which can be mixed. Liquid which mix together in all proportion from a single layer are called miscible liquid.
Mm-hmm.
Just like salt and water example, which you just saw right now. And immiscible substance which cannot be mixed.
Yeah. It's like oil and water.
Oil and water. There could be many things. They are separated by using a separating funnel, mainly filters, we can say.
Mm-hmm. Yeah.
Mainly filters.
Mm-hmm.
Okay. So these terms you should note of miscible and immiscible. So we can kindly move to the slide number 14.
Okay.
Now it is talking about
Mm-hmm.
the objects and its appearance. Yeah, appearance of matter it is telling. So we have, must have read in earlier classes, class 5. I hope you have read that there are three types of material in solid: transparent, translucent, and opaque.
Yeah.
So just you give me an example of translucent, not from this, on your own.
Translucent is like it can go some of it can go through, but not all of it.
Yes, yes. Hmm.
Mm-hmm. An example of it would be transparent piece of paper.
Okay. So opaque is an object through which light cannot pass.
Yeah,
Anything solid.
part of the light can pass through it.
Ah, but translucent is something where a part of a light will pass. For example, edged view, the glasses which is edged. For example, the window which is just behind you or just beside you. So that is an opaque. I can't see all the lights coming in. But yes, few lights are coming. So it is acting like a translucent object. Transparent where all the lights can pass, just like a transparent glasses.
Mm-hmm.
Okay, so this is properties of materials, like some can
Mm-hmm.
be hard, soft, smooth, rough, rigid, shiny, dull, waterproof, leaky. Okay, so you have to match it. You have to match it. Can you match which hard among these, which will be hard?
Which one would be hard? Like the table?
Table. Wood. You mean wood?
Yeah.
Okay, which will be soft?
Soft would be like the plastic bag.
Okay, smooth,
What?
smooth.
Smooth would be like paper.
Hmm. Okay, then you tell me rigid. Rigid. Among these, which is most rigid?
Opaque. I said opaque.
You said
Opaque.
opaque.
Mhm.
Rigid means among these,
Mm,
among the right side, you can see na wood, metal, wool, plastic, leathers are written. Are you in slide number
yeah,
15 na?
15.
15.
Yeah.
So I'm asking now, which material is rigid among all these? Most rigid.
Rigid. Um,
What do you mean by rigid object?
like like soft
No, no,
surface.
no, no, no. It's opposite of soft. It's very hard. Rigid is very,
Cannot be
very.
opaque.
It cannot
That's
be
what I said
cold.
before.
So among all these, which material you will put into the correct column of rigid?
Um, wood,
No, there is something which is more rigid than wood.
coin,
Which one?
coin,
Coin. Coin is made up of?
like copper.
Yes. So you say metal, na? Simply you say metal. It is written na metal over here.
Mm-hmm.
See, it is written na metal. So this metal is actually the most rigid, hard, hardest substance. Okay, so but what has happened? Wait, we will do few questions. Okay.
On which page? 16?
Hmm?
16?
I'm coming. I'm coming. I'm coming.
Okay.
You come to slide number 23.
Okay.
And you solve the first question only.
Wait, I need to like, yeah. Okay, so the homogeneous and heterogeneous salt solution. The salt solution is like is hetero. Hello?
Homogeneous and heterogeneous. So you tell me which one is homogeneous. Just pick out the homogeneous.
Yeah, salt solution is
Solve solution
homogeneous.
homogeneous. Next.
Um, what's charcoal?
Charcoal, coal. The
Um,
black one which you use to cook.
okay. And then sand and coal, charcoal.
Sand and charcoal are heterogeneous. When you will mix, when you put charcoal means coal.
Mm-hmm.
When you put sand on the coal, so it is easily separable, na? Easily separable. Two different material. Hetero. Homo means same. Hetero means different. So charcoal and sand is a
Just
heterogeneous.
water, seawater
Seawater is
is,
homogeneous. Yes.
and then fruit juices.
Fruit juices is not homogeneous. It is heterogeneous because in fruit juices we have pulps also. We have the rashes of the fruits. It's not as pure as water, no?
What is brass?
Brass is a metal. It's look like a copper type. It's a brass where you, in the tap.
Yeah.
Generally, it is used in the tap in the
Yes.
washroom. Na
Yeah,
washroom use the tap. Na it is made up of brass.
brass is also homogeneous.
Okay. What are the
Mm,
heterogeneous then?
uh, petrol and water, and sand and charcoal, alcohol and water, air dissolved in water, fruit juices and mist.
Hmm.
Hello?
Very good. Very good.
Mm-hmm.
And in the question you can see na fourth question. Come to the fourth question.
Okay.
Okay, the third is the answer is already given. Second answer is already given.
Mm-hmm. The 4th one? Incorrect reason for separation. Components of a mixture.
Incorrect reason.
Okay. It's I.
It's 1, 2, 3, 4. Look at solid 1, 2,
One.
3, 4.
One.
1 is wrong. Select an incorrect reason for separating component of mixture. To separate two or more different but useful component. So it is a correct reason, na? We separate two different mixtures to get a useful component. Suppose gold is mixed with copper, so you will leave it. We will extract the pure gold, na?
Two.
2 is also wrong. To remove undesirable and useless component, we use separation method to remove undesirable and useful compound. The correct answer is 3, to remove pure or harmless components. When we have a pure component, why we will need to filter it out? When we have a pure water, why again you will put in a filter and when again put in a RO and then you will drink it? Will it be a useful for us? When we have
No.
already have a pure juice, why we will again filter it?
Mm-hmm.
So if you have a pure substance, there is no need. I think you didn't understand the question. The question was saying, na, select an incorrect reason. For which reason we don't need separation method?
Mm-hmm.
For what reason we don't need a method which is needed for separation? So we don't need the method to separate a pure substance. That is the answer. Clear?
Okay.
Okay, so time is over. So I would like to end the class. If you want to ask any question or if your parents want to interact.
Are you able to hear me?
Yes, ma'am. Good evening. It's evening
Good
here.
evening.
It's night here almost. Yes, ma'am.
Yeah, the class was good, but yeah, I would like to see you having more interactions with him, questioning, asking him more questions so that it will be good. I mean, he will be more involved in the class. That
Sure.
is one of the feedback. Yeah.
Okay.
And also one more thing, actually, I'm looking for daily half an hour classes for my son and daughter. My daughter is she's going to third grade, and my son he's in sixth grade. So I'm just looking for daily classes, weekly 5 days, and daily classes for half an hour, so that they will be having the daily practice to do the questions related to the Olympiad.
But that is not an issue. So one
Mhm.
positive feedback. The feedback is very important, ma'am. Okay, now because we are experienced teacher. That doesn't mean that we can handle every student. So every
Mhm.
student learning pace is different. So it was my first interaction. So I got to know many things about him. But you being a parents, you know your child much better than me because this was my
Mhm.
only 1 hour of duration. So your feedback, I take it very much positively. So yes, it will be more interactive and the design of slides will be in a such a manner na, that the student will automatically respond. This was the first class I was going through the theory parts, but my teaching
Mhm.
style is I will teach one topic, two topic, and ask the questions. Teaching two topic, one topic, ask the question, so that it makes the student interactive and the learning output can be seen also, whether the student is concentrating or not concentrating. So that is not an issue. And the second thing is you inquired about the half an hour of classes. This means I have to give 1 hour class for both of your child. So
Yes.
what will be that Indian timing? That is very important.
Yeah. I have given the coordinator. Yeah.
You can keep at 10 to 11 is fine for me. 10 to
Sure.
11 is fine for me.
Whether they have. Not 10 to 11. We have different timings on different days.
Okay, so you just give your own timing, and we will discuss with the team. The team will reach you out. So you can give the timing. But I got a timing actually. Uh,
Mm-hmm.
I got a timing got a timing of in Indian time is one time is 6:30 a.m. One other time was 5 a.m. Another time was 4 a.m. So I requested at 4 a.m. It's very difficult. You can imagine how I can wake up, or how I will when I will wake up, when I will sleep, or maybe I am sleeping and the student is waiting. So that becomes very embarrassing. So I just requested and don't keep that risky timing. So either you can keep in the morning in Indian timing, or you can keep in the late evening. So morning time in India time is also fine for me, and evening time is also fine for me. The timing is a issue because I take classes, so timing is a issue, but it's not a big deal for the US students because here the most of the peak hours are over. So your daughter is in grade 3, na? Hello.
Right, correct.
Actually, grade 3. Okay, she has moved to grade 3, and she also preparing for Olympiad. So science subject she will be taking.
Yes.
Okay, it's not an issue. Anything else, ma'am?
No.
So your son has performed very well, and
Mm-hmm.
the knowledge, understanding, and learning is very well.
Mm-hmm.
So I will enjoy teaching him. And this was the first basic topic. So he knows most of the topics he already knew. Maybe he
Mm-hmm.
has learned somewhere, or maybe he has read, or maybe, but he know knew most of the topic. But what actually happened is today I have taught him, and approximately 9 to 10 new terms he has read. For example, homogeneous, heterogeneous, and
Mm-hmm.
diffusion, fusions. So those are the terms which he has read. So the continuous class will make us how much he has retained, how much he is applicable to those terms, whether they're understanding or just memorizing those terms. So you tell me him to please revise the
Yeah,
thing.
I'd like to do one more thing.
Yes, ma'am.
Providing daily homework in the portal. Do you have something sort of kind providing homework daily in the portal?
Homework.
Mm-hmm.
It's very easy now. We can send the questions accordingly. Now, what topic we have sent, but what topic we have taught. We will do the
Mm-hmm.
practices in the classes in half an hour, and we will send the 4, 5, 6 questions, or around sometime 10 questions as per the topic, so that they can be touch minute. That's not a big issue. Availability, we have thousands of questions available grade wise.
Okay. Is it going to be in the portal and you would be reviewing those questions on a daily basis in the sessions, or how those things will be handled? I just want to know.
Okay, the one way is that I will share the question right now after the class.
Mhm.
One way is in the portal also. So portal, I'm not very much sure how it works. So the team will reach you back, ma'am, for the portal thing. Okay.
Mhm.
They have a very dedicated platform in the website. So how
Mhm.
it will work for these grades, that the team, you have to connect the team, they will guide you. But personally, as a teacher, when you will ask me, yes, we have a lots of question, and we can share it, and we can share over the here, we can share over the WhatsApp, we can share it, and the students can share back the answers, and we can discuss in the next class.
Mhm. Okay.
Okay, ma'am, shall I leave?
Oh, yeah. Yeah.
Okay,
Thank
thank
you.
you. Thank you very much. Thank you.
Yeah. Bye.
Bye bye.